Hi everyone, today we're going to be going through the product and quotient rules for derivatives. So we're going to give you those rules first and then do a couple practice problems for each. So the first thing we're going to talk about is the derivative of a product. So if f of x and g of x are both differentiable functions, then we say that the derivative with respect to x of the quotient, or excuse me, the product f of x times g of x is equal to, we take the first function times the derivative of the second function, and then we add basically the reverse, the second function times the derivative of our first function. So that's our product rule. The second rule we have is for quotients. So now if we again have f of x and g of x are differentiable functions, then the derivative with respect to the x of the quotient of f of x and g of x looks like this. We take the function in the denominator, g of x, times the derivative of the function in our numerator, minus the function in the numerator times the derivative of the function in the denominator all over our denominator squared. Now in class when we talk about this, you'll hear me say low d high minus high d low all over low squared. So here's what we mean. When we say low, we take the function from the denominator. D high means the derivative of the function in our numerator, minus high, that's the function in the numerator. D low is the derivative of the denominator. All over low squared means the function in the denominator squared. So low d high minus high d low all over low squared. So let's see what this means for us in terms of actually finding these derivatives. So it'd probably be maybe helpful to use some color. So let's say I have f of x, and I've got the product here of x squared plus 1 times, I'm going to use red so it stands out a little more, x cubed plus 3. So all I've done there is rewrite it so I don't have any derivative notation. So now for f prime of x, here's what we're going to do. We're going to take the blue function, the first one, and just copy it as is. And I'm going to multiply by the derivative of my second function, which is going to give me 3x squared. And then we're going to add, I'm going to take my second function, x cubed plus 3, and I'm going to multiply by the derivative of my first function, which is 2x. Now, we could distribute these terms and simplify. For our purposes right now, I just want to know that you understand how these rules work, so we're not going to focus on the simplifying at this point. That'll come a little bit later. All right, let's look at number 2. So we have the function f of x equals x squared minus 1 over x squared plus 1. So again, I'm going to use color here. I'm going to make my numerator blue. And then my denominator will make red. All right, so when we differentiate, we said we take our bottom function, so x squared plus 1 times the derivative of our top function, which is 2x. Now we're going to subtract our function in the numerator, x squared minus 1, times the derivative of the function in our denominator, which is 2x. And that's all going to be over our x squared plus 1 quantity squared. Again, I'm not going to do any simplification here because for right now I just want to know that we have the parts of the rule down. All right, for number 3, I actually want to show you a couple of ways to do this because it's actually, you can use product rule, but it's not the only way to do this, and I want to make sure everyone kind of understands the different options for approaching this problem. So if I can get this set right. So the first way we could do this is just to treat it as product rule. So we're doing 1 plus t and times the square root of t. I'm going to call this t to the 1/2. So I could say s prime is equal to my first function, 1 plus t, times the derivative of the second. So it's going to be times 1/2 t to the negative 1/2. Then I would have plus t to the 1/2 times the derivative of my blue function, which is just 1. Now, I'm not going to concern myself too much with simplifying, but I do want to rewrite these as radicals since that's how the original problem was written. So I have 1 plus t times, I'll probably pull this out front, 1/2 times, oh wait, I messed that up. Hold on a second. So I've got 1 plus t. I'm realizing this is negative. So actually, this would all be over. My 2 would be down in the denominator, as well as my root t. And then I would have plus the square root of t. That's one way of doing this problem, using the product rule. However, I could also do it another way. If I wanted to, I could just distribute the square root of t to both terms. So I would get the square root of t plus, now here I have t to the first power times t to the 1/2. I know when I multiply those, I'm going to add those powers together. So I'm going to have plus t to the 3/2 power. Now, I actually have an expression here where I could just use my power rule to go ahead and take that derivative. So let's put that over here. I'm going to take that derivative here. If my function is s equals the square root of t plus t to the 3/2, now I don't need product rule at all. I just have s prime equals 1/2 t to the negative 1/2 plus t to the 3/2. And that would be my answer. So I just want to show you that as we go through, you will sometimes have some flexibility in how you handle these. Some people prefer to just distribute and use the power rule, while other people will prefer to use product rule. All right. Our last one, number 4, we have another quotient rule here. So y equals, let's make our denominator or numerator in blue. And I'll do the denominator in red again. All right, so in terms of working through this, we said we're going to start with our x plus 5, our low, d high, which is the derivative of the top, so 3x squared plus 4x, minus high, so that's my numerator, d low, the derivative of my denominator is just 1, and I have all over low squared, or that x plus 5, quantity squared. And again, we're not going to concern ourselves here with simplification. Okay, so that's kind of a quick run through of those rules, and we'll work through it some more in class tomorrow. See you then.